Okay, so here we'll find the max and the min of fxyz, that is x plus y minus z, over the sphere x squared plus y squared plus z squared equal 1. Now the way to approach this problem is via Lagrange multipliers. So if I call my constraint minus 1, this is the constraint here. So I gotta find the max and min of fxyz subject to gxy z is equal to 0. To solve that, we solve the Lagrange multipliers. We need that the gradient is equal to the gradient gxyz. Now also note that if x squared plus y squared plus z squared, the gradient of g at the point xyz is 2x, 2y, 2z, which is different than 0, 0, 0 if x squared plus y squared plus z squared is equal to 1. And then we have that g, x, y, z is equal to 0. Now, here we just solve the system. So what is the gradient of f at xyz? The x component will be 1. So, I mean, this is just fx xyz is equal to lambda gx xyz fy xyz is equal to lambda gy xyz, and fz xyz is equal to lambda gz xyz, and that x squared plus y squared plus z squared is equal to 1. Great. Now this system is equivalent to what? To 1, because the derivative of f with respect to x is 1. Recall that fxyz is x plus y plus z, so 1. And the derivative of g with respect to x is just 2x. So lambda times 2x. Same thing for y. Lambda times 2y. And for z, it's minus 1 times lambda times 2z, along with the fact that x squared plus y squared plus z squared is equal to 1. Now the idea is to try to divide by lambda here. Right? We need to solve. All we need to do is to express x in terms of lambda. That seems a very good way here, and use the fact. So if we express x, y, and z with respect to lambda, and we can then solve x squared plus y squared plus z squared is equal to 1, provided that lambda is different than 0. But this is clear. Lambda is different than 0, because if lambda were equal to 0, the first equation would give us 1 is equal to 0. This is the first equation. So this is absurd, a contradiction. And hence, x will be equal to 1 over 2 lambda, y will be equal to 1 over 2 lambda, and z would be equal to minus 1 over 2 lambda. Now we use the fact that x squared plus y squared plus z squared is equal to 1 to get that 1 over 4 lambda squared plus 1 over 4 lambda squared plus 1 over 4 lambda squared is equal to 1. This gives us that 4 lambda squared, or we can add these together. We get 3 over 4 lambda squared is equal to 1, which implies that 4 lambda squared is equal to 3, and this implies that lambda is plus or minus root 3 over 2. So if lambda is equal to root 3 over 2, xyz would be equal to 1 over 2 lambda, which is 1 over 2 lambda. So 2 lambda would be equal to 3. So 1 over 3 1 over 3 and minus 1 over 3, root 3, sorry, root 3, root 3. Or if lambda is equal minus root 3 over 2, xyz would be equal to minus 1 over root 3, minus 1 over root 3, and 1 over root 3. Now, we look at the image of the points that I obtain, and what do I get? I get x plus y minus z, which is then 3 over root 3, which is root 3. And then I look at this image, which is minus 1 over root 3, minus 1 over root 3, plus, or minus, it's minus z, which is minus 1 over root 3, which is minus 3 over root 3, which is minus root 3. Now, what is the bigger value? The biggest of these two is root 3. So the absolute max of fxyz subject to gxyz, or let's write it this way, to x squared plus y squared plus z squared equal 1, is root 3, and the absolute min is minus root 3.